Now what we're going to look at today is reversing the direction of rotation of a motor. So I have my motor here. I'll come back to the circuit board in a minute. So if I just turn it on, it should be going, I think, anti-clockwise. Which is kind of hard to see, but you can't see it when it stops rotating. Okay, just when it slows down. So it's going anti-clockwise. Now, one of the ways of just reversing the rotation of that is just simply to change the wires. Bring that one over there and that one over there, and it will change direction. Another way of doing it is, and that would be rather tedious, you couldn't be doing that in a factory or anything like that. Okay, so what we're using here is the dual coil latching relay to switch the direction. Again, we're going to activate the coils on the relay with these reed switches as we've shown before. And so I just set it running. Again, it's going anti-clockwise. And if I activate this one, it goes anti-clockwise the other way. You just see when it slows down that it is actually going clockwise. And switch it back. Just turn it off. So there, that's how we turn it clockwise and anti-clockwise. Now the principle of operation of the circuit is based on a H-bridge. A H-bridge is a kind of a known method of switching the direction of current. So you have a motor here, and if you have S1, switches S1 and S2 closed, the current goes that way, drives the motor in a particular direction. If you have those two open and you contact switch 3 and switch 4, you can see the current will go in a different direction. So what I've done in the circuit is we have a relay, and we've two sides to the relay. So this represents one side of switching and this represents the other side. So the motor is directly connected to common on one side, common on the other side. Normally closed on one side, normally open on the other side. And equally over here, we've normally open, normally closed. So this is our diagram of how it's connected on the actual relay. Now there are the two coils there, right, that we activate with the reed switches. I'm not showing the connections for those, it just gets a bit messy. But what we have, the motor is connected through common on that side, common on that side. So when the relay is, shall we say, in its unswitched position, you've got your current coming down through here, normally closed, through common, around back here. This side it goes through common and normally closed to ground. When you flick the relay, if you like, switch it around by activating the coils, what's going to happen then is we now have our current is going to come down here through normally open, go through common. You can see that I'm going in a different direction now. Go through common this side and to normally open back down to ground. So we'll just look at the circuit again and show you the connections. So here's the little breadboard again. I know it's one awful mess, tangle of wires, but once you've drawn your circuit diagram, you can follow it, and then you won't get lost. But you've got to double check a couple of times. You got your relay here. Our coils here have been activated through our relays here going to ground. And when I talk about your different sides, as I've said before, the relay has two circuits on either side. So circuit that side, common, normally closed, normally open. On this side we've common, normally closed, normally open. And when we combine them, the way shown, we can have our circuit going backwards and forwards. So just do that one more time. Turns around, as you can see. So where might we use that? Well, we might have a conveyor driven by a motor, and the conveyor travels down the length of the assembly line, and then you want it to reverse direction when it comes in contact with the other end. So you could have a reed switch on one end when the conveyor goes down to the end, some magnet will activate the reed switch, switch its direction, and it comes back up again. So you've got up and down automatically. So you could have that in a conveyor. Again, you might want to switch direction of your motor. Maybe it's driving something else, you want to go backwards and forwards. Again, because we have the latching relay, again it stays in reverse, stays in forward or back, depending on which coil you've activated. Finally, now you might not want to activate the coils, if you like, automatically with sensors. You might just want to do it manually, and that might be fine on a conveyor belt. That the operator sees the conveyor, travels to the end, and you just reverse direction of the motor. So this little guy is quite handy. This is kind of a common here, and then when I switch to here, I'm switching to one of the coils on the relay, and I switch to here, I'm going to the other coil. So it's powering up the coils, flicking back and forward, kind of toggle arrangement. So if I just turn on the motor again, and again, I can see if I go over here, I've changed direction. You can see it's going clockwise, or sorry, anti-clockwise. Go back over here, it goes clockwise. I know it's hard to see it, but it's only kind of when it's slowing down that you just see the change of direction. But that's a nice handy way to control things. So there's no need to be, always looking to automate things. It depends what you want to do. And again, you can kind of use simple circuits, simple buttons and switches initially, and then you can kind of up the ante and go for sensors, be it a reed switch or a proximity switch or the IR sensor or whatever. But sometimes something very simple like this would work very effectively. So okay, that's your reversing motor direction. Over and out.